Okay, guys, so I'm going to do this problem. This is a nice problem. I really like it. I think A and B, everybody can definitely do. Um, and then part C, only if you've gotten, I think I said through J6, would you maybe have an idea of how to do that? Okay, so we've got this table above. Right? The functions f and g have continuous second derivatives. The table above gives values of the functions and their derivatives at selected values of x. So for part A, let k of x equal f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. Okay, so guys, for part A, you need to know this formula for the equation of a tangent line. So it's y equals, now it's usually I give you the formula with f, but it's with k this time. So just a minute. Okay, so it's going to be k of 3, because they want to add 3, plus k prime of 3 x minus 3. Okay, that's a formula that we need to know. Now we've got to find k of 3. Okay, so first, k of 3 is equal to f of g of 3. And we're going to use the table above to find that. So this is going to be f of, let's find g of 3. So there's the g column, there's 3, so 6. And then f of 6, there's 6, there's f of 6 is 4. Okay, so 4 is going to go right in there. Now we've got to find k prime of 3. So first, let's just find k prime of x. Okay, so up here, let me just point this out. Okay, so when we take the derivative of that, we're going to need to do, you got to think chain rule. So g of x is the inside, and then f of blank is the outside. So when we do k prime of x, the derivative of the inside is g prime of x. The derivative of the outside is f prime of blank, and then g of x goes back in. Okay, so now we got to do k prime of 3. So this is going to be g prime of 3, f prime of g of 3. G prime of 3, so there's the g prime column, 3, so that's 2, times f prime of, so here I need g of 3, so there's the g column, 3, so 6, so this is 2 times, there's the f prime column of 6 is 5, equals 10. Okay, now I'm just going to put those things in here. So y equals, so k of 3 is 4 plus 10 x minus 3. Okay, so that is the answer for part A. All right, now let me separate my work nicely. I'll go like this. Okay, now we're going to do part B. So let h of x be g of x over f of x, find h prime of 1. So guys, to take the derivative of something like this, you need the quotient rule. So this is for part B. So h prime of x is the derivative of the top, and then bring over the bottom, minus the top, and then the derivative of the bottom, all over the bottom squared, okay? That is the quotient rule. Okay, it looks a little blurry. All right, so now I gotta plug 1 in. So h prime of 1, g prime of 1 f of 1 minus g of 1, f prime of 1. Yeah, I like this problem because you just really have to know, you just have to have strong skills, and then it's pretty straightforward. There's not a whole lot of interpretation here. Okay, and then, so we've got h prime of 1. All right, so g prime of 1. All right, so there's the g prime column of 1 is 8. All right, sorry, I want you to be able to see everything. So let me maybe zoom out. Okay. So G prime column 1, 8. F column 1 is -6. G column 1, 2. F prime column 1, 3. All over F column 1, -6. Okay, so H prime of 1, all of this up top ends up being -54 all over 36. And guys, when I looked at their rubric, they did simplify that to, I forget what it was. Okay, so 9 goes into both of these, right? This divided by 9 is 6. This divided by 9 is 4. And then 2 goes into them. So I think it was like -3/2, maybe I'm right. But you don't have to simplify your answers. Okay, in the free response section, you do not have to simplify your answers. So, I'll just leave it like that. Okay, and now we have the last part. So this very last part, this is nice. Now, if you've gotten to J-6, you should have an idea of how to do this. Okay, so let me do it. So this is part C. So we've got the integral from 1 to 3 f double prime of 2x dx. Okay, so we need to use u substitution. All right, if this was just f double prime of x, then to take its antiderivative, so that the antiderivative of f double prime is f prime, because you'd be going backwards just one derivative. But this is, so we have to use the fundamental theorem of calculus, so we're going to have to do the brackets, put these endpoints on the other side, put the antiderivative on the inside. But just like I said, this is not f double prime of x, it's f double prime of 2x. So we're going to have to let u equal, 2x, all right? So let u equal 2x. So then, all right, so if u is equal to 2x, so this integral is changing, the endpoints of the interval are changing. Right now, these are x values. All right, x equals 1 to x equals 3. We need them to be u values. So if I plug 1 in here, so when x is 1, u is 2. When x is 3, u is 6. All right, so the x interval 1 to 3 becomes the u interval 2 to 6. Okay, and now I got to change the rest of it by doing this. So du is, you take the derivative 2, and then you put a dx. And then I solve for dx. So dx is a half du. So now this becomes f double prime of u, and then in for the dx, I put 1/2 du. 1/2 du. Okay. Now you can pull the 1/2, the 1/2 is a constant. So you could pull it out front. And then this is f double prime of u du. Now I can do the fundamental theorem of calculus. So the fundamental theorem of calculus goes like this. If you have a coefficient out front or a constant out front, you bring it down. I change, so this becomes a bracket. The du becomes a bracket, and then this 2 and the 6, they go over here. And then the antiderivative goes inside of here. So what is the antiderivative of f double prime of u? It's f prime of u. Okay? And now the fundamental theorem goes like this. So that was just the first part of the fundamental theorem. Now I plug in the top, f prime of 6, minus, plug in the bottom, f prime of 2. So this is 1/2. Now I'm using values for so I need f prime of 6 and f prime of 2. So let me go up here. Here is the f prime column of 6. F prime of 6 is 5. F prime of 2 is -2. Okay, so f prime of 6 is 5 minus -2. All right, so that's actually 5 plus 2, which is 7. So it's 1/2 times 7, so that's 7/2. There it is, guys. If your skills are sharp, you can do that. There will be problems on the AP exam that are straightforward like that. There always are.